All right, we've made it to the final video of our bridge program, and this is by far the toughest one, chain rule number 3. It is actually a double chain rule. Now, when you get this rule, you're going to feel really good about yourself. Honestly, sometimes it takes kids a little while to understand this one, and that's okay. So if you're not 100% confident, I don't want you to give up on it. You will get it eventually, I promise. So here's what a double chain rule looks like. This is now sine squared of 6x cubed. Okay, so the first thing we said is of. So I'm going to put my parentheses around the of. Sine squared of 6x cubed. So there is my first inside. Now, the second inside comes when I rewrite this. So I'm not doing any calculus, I'm just simply rewriting this function. Now, you know in trig that we always put that squared term on actually the sine or cosine function, but it has to get rewritten. So let's star this and make sure we rewrite this correctly. This is really the sine of 6x cubed, close those parentheses, all squared. Okay, so let me show you where my two insides are. Here was my first inside, which was hopefully obvious. Now here's my second inside. All of this is inside the squared. So this is why it's called a double chain rule. There are two insides. So I'm going to walk you through one, and we'll just do a bunch of, practice problems till we're getting close. So I'm going to start by taking the derivative of the outside. Now the outermost function is this squared term up here. Correct? This is the outside. So I'm going to start with the outermost function. It's a power, so I'm going to treat it like the power rule. I'm going to bring the 2 down. I'm going to leave the whole inside. So that's the sine of 6x cubed. And now this will be raised to the first. Now I have to multiply by the derivative of the first inside, or the bigger inside, which is this guy. So my first inside, I'm just going to write off my first inside, is the sine of 6x cubed. Okay, that's my first inside. So I'm going to take the derivative of its outside, which is sine, so its derivative is cosine, leave its inside. Now I have to multiply by the derivative of the next inside, which that was 6x cubed, so I'm going to multiply by 18x squared. And I'm going to slow down and talk that out one more time, but that is the entire chain rule derivative. So I identified my two insides, my obvious one, and then my bigger one, and then this would be my outside. So I'm going to take the derivative of the outside, so that's the power, so I'm treating it as the power rule, bring the 2 down, leave the entire inside, subtract 1, and I get 1. Now I'm going to take the derivative of the big inside. So I just wrote it off to the side for myself. This is the whole inside, so I have to take its derivative. Now it's also a chain rule because it has an inside and an outside. So I'm deriving its outside, keeping the inside, and now times the derivative of that final inside to get this. And then lastly, I'm just going to clean it up so I can multiply any constants together. So this guy and this guy. So that's 36x squared. And then I'm just going to write down what I have. The sine of 6x cubed and the cosine of 6x cubed. And that is my final answer. All right, so let's try another example. Take the derivative of cosine to the 4th of 3x to the 5th. So again, you don't really see the double chain rule until you rewrite it for yourself. So we said the cosine of 3x to the 5th, and it's the cosine to the 4th, so that's all raised to the 4th. So if you like brackets better, feel free to use brackets. Big parentheses, brackets, whatever works for you. Okay, so I'm going to identify my inside. There's an inside. And then this is also the next inside. And this 4 is hopefully clearly on the outside. So I'm going to start by taking the derivative of the outside, which happens to be a power. So I'm going to apply the power rule, which says bring down the 4, leave the inside. Now I have to subtract 1, so this is now going to be to the 3rd power. Okay, so now times the derivative of the inside. So if it helps, you can rewrite your inside off to the side. The inside is cosine of 3x to the 5th. So I'm going to take its derivative, and it has an inside and an outside. So the derivative of cosine is negative sine. Keep its inside, so 3x to the 5th times the derivative of that inside, which would be 15x to the fourth. And there you have it. So now I would just clean it up from this point. So I can multiply any coefficients together. So let's see, I can multiply the 4, the negative, and the 15x to the fourth. So 4 times 15, that's 40 and 20, that's 60. So negative 60x to the fourth. So that took care of that term, and that term. Then I have the cosine of 3x to the fifth. Now I'm going to put that cubed back on the cosine term. And then I have the sine of 3x to the fifth. And that would be our final derivative. All right, we've made it to our last example. And again, I want to practice saying it out loud and rewriting it. This is the secant to the sixth of 2x cubed. So again, let's rewrite it. So this is really the secant of 2x cubed, and it's all of that raised to the sixth. So step 1 is to rewrite. Okay, so I've got my inside, my second inside, and then my outside. So derivative of the outside, so there's my power, leave the inside. Subtract my 1, times, now I need the derivative of the inside. So again, if it helps, write out that inside off to the side for yourself. This is who I now have to take the derivative of. Well, if you look at your derivative rules, the derivative of secant is secant tan. But again, it's secant, keep the inside, tangent, keep the inside, and now times the derivative of its inside, so times, I'm running out of room here, 6x squared. Okay, so lastly, I'm just going to clean it up and multiply anything I can together. So it looks like the 6 and 6 make 36x squared. Then I have secant to the fifth of 2x cubed, secant of 2x cubed, and tangent of 2x cubed. Now there's actually one more move I can do on this part because hopefully you noticed you have secant of 2x cubed times secant of 2x cubed. There's 5 here and 1 here. I really can say that's secant to the sixth of 2x cubed times the tangent of 2x cubed. Well, like I said, if you don't have this down, please do not stress about it. There's some practice problems, but we can come in and work with us either Tuesday or Thursday. And again, we've got months of practice during the school year.